World energy consumption refers to the total energy used by all of human civilization, typically measured per year. It involves all energy harnessed from every energy source applied towards humanity's endeavors from across every single industrial and technological sector, across every country. Being the power source metric of civilization, world energy consumption has deep implications for humanity's social, economic, political sphere. Institutions such as the International Energy Agency, the U.S. Energy Information Administration, and the European Environment Agency record and publish energy data periodically. Improved data and understanding of world energy consumption may reveal systemic trends and patterns, which could help frame current energy issues and encourage movement towards collectively useful solutions. The IEA estimated that in 2012 the world energy consumption was 13,371 mtoe, or 5.6 times 1020 joules. From 2000 to 2012, coal was the source of energy with the largest growth. The use of oil and natural gas also had considerable growth, followed by hydropower and renewable energy. Renewable energy grew at a rate faster than any other time in history during this period, which can possibly be explained by an increase in international investment in renewable energy. The demand for nuclear energy decreased, possibly due to the accidents at Chernobyl and 3 Mile Island. In 2011, expenditures on energy totaled over $6 trillion US dollars, or about 10% of the world gross domestic product. Europe spends close to 1/4 of the world energy expenditures, Americans close to 20%, and Japan 6%. Overview: energy supply, consumption and electricity. World total primary energy supply, or primary energy, differs from the world final energy consumption because much of the energy that is acquired by humans is lost as other forms of energy during the process of its refinement into usable forms of energy and its transport from its initial place of supply to consumers. For instance, when oil is extracted from the ground it must be refined into gasoline, so that it can be used in a car, and transported over long distances to gas stations where it can be used by consumers. World final energy consumption refers to the fraction the world's primary energy that is used in its final form by humanity. In 2012, world primary energy supply amounted to 155,505 terawatt-hour or 13,371 mtoe, while the world final energy consumption was 104,426 terawatt-hours, or about 32% less than the total supply. World final energy consumption includes products as lubricants, asphalt and petrochemicals which have chemical energy content but are not used as fuel. This non-energy use amounted to 9,404 terawatt-hours in 2012. The world's electricity consumption was 18,608 terawatt-hours in 2012. This figure is about 18% smaller than the generated electricity, due to grid losses, storage losses, and self-consumption from power plants. Cogeneration power stations use some of the energy that is otherwise wasted for heating buildings or in industrial processes. The United States Energy Information Administration regularly publishes a report on world consumption for most types of primary energy resources. The most recent estimate of the world energy consumption was 5.59 times 1020 joules, or 155,505 terawatt-hours, in 2012. According to the IEA, the total world energy consumption was 143,851 terawatt-hours in 2008, 133,602 terawatt-hours in 2005, 117,687 terawatt-hours in 2000, and 102,569 terawatt-hours in 1990. The world electricity consumption was 18,608 terawatt-hours in 2012, 16,503 terawatt-hours in 2008, 15,105 terawatt-hours in 2005, and 12,116 terawatt-hours in 2000. In 2012, approximately 22% of world energy was consumed in North America, 5% of world energy was consumed South and Central America, 23% was consumed in Europe and Eurasia, 3% was consumed in Africa, and 40% was consumed in the Asia-Pacific region. In 2012, world energy consumption by power source was oil 31.4%, coal 29.0%, natural gas 21.3%, biofuels and waste 10.0%, nuclear 4.8%, hydro 2.4%, and other 1.1%. Oil, coal, and natural gas were the most popular energy fuels. Recently there has been a large increase in international agreements and national energy action plans, such as the EU 2009 Renewable Energy Directive, to increase the use of renewable energy due to the growing concerns about pollution from energy sources that come from fossil fuels such as oil, coal, and natural gas. One such initiative was the United Nations Development Programme's World Energy Assessment in 2000 that highlighted many challenges humanity would have to overcome in order to shift from fossil fuels to renewable energy sources. From 2000 to 2012, renewable energy grew at a rate higher than any other point in history, with a consumption increase of 176.5 million tons of oil. During this period, oil, coal, and natural gas continued to grow and had increases that were much higher than the increase in renewable energy. The following figures illustrate the growth in consumption of fossil fuels such as oil, coal, and natural gas as well as renewable sources of energy during this period. Trends: the energy consumption growth in the G20 slowed down to 2% in 2011, after the strong increase of 2010. The economic crisis is largely responsible for this slow growth. For several years now, the world energy demand is characterized by the bullish Chinese and Indian markets, while developed countries struggle with stagnant economies, high oil prices, resulting in stable or decreasing energy consumption. According to IEA data from 1990 to 2008, the average energy use per person increased 10%, while world population increased 27%. Regional energy use also grew from 1990 to 2008. The Middle East increased by 170%, China by 146%, India by 91%, Africa by 70%, Latin America by 66%, the USA by 20%, the EU 27 bloc by 7%, and world overall grew by 39%. In 2008, total worldwide energy consumption was 132,000 terawatt-hours or 474 exajoules. This corresponds to an average global power demand of 15 terawatts. In 2012, energy demand increased to 158,000 terawatt-hours, equivalent to an average power use of 18.0 terawatts. Energy consumption in the G20 increased by more than 5% in 2010 after a slight decline of 2009. In 2009, world energy consumption decreased for the first time in 30 years by 1.1%, or about 130 million tons of oil equivalent, as a result of the financial and economic crisis, which reduced world GDP by 0.6% in 2009. This evolution is the result of two contrasting trends. Energy consumption growth remained vigorous in several developing countries, specifically in Asia. Conversely, in OECD, consumption was severely cut by 4.7% in 2009 and was thus almost down to its 2000 levels. In North America, Europe and the CIS, consumption shrank by 4.5%, 5% and 8.5% respectively due to the slowdown in economic activity. China became the world's largest energy consumer since its consumption surged by 8% during 2009. Oil remained the largest energy source despite the fact that its share has been decreasing over time. Coal posted a growing role in the world's energy consumption. In 2009, it accounted for 27% of the total. Most energy is used in the country of origin, since it is cheaper to transport final products than raw materials. In 2008, the share export of the total energy production by fuel was oil 50%, gas 25% and hard coal 14%. Most of the world's high-energy resources are from the conversion of the sun's rays to other energy forms after being incident upon the planet. Some of that energy has been preserved as fossil energy. Some is directly or indirectly usable, for example, via solar PV, thermal, wind, hydro or wave power. The total solar irradiance is measured by satellite to be roughly 1361 watts per square meter, though it fluctuates by about 6.9% during the year due to the Earth's varying distance from the Sun. This value, after multiplication by the cross-sectional area intercepted by the Earth, is the total rate of solar energy received by the planet. About half, 89,000 terawatts, reaches the Earth's surface. The estimates of remaining non-renewable worldwide energy resources vary, with the remaining fossil fuels totaling an estimated 0.4 yatajoule or 4 times 1023 joules, and the available nucleofuels such as uranium exceeding 2.5 yj. Fossil fuels range from 0.6 to 3 yj if estimates of reserves of methane clathrate are accurate and become technically extractable. The total power flux from the Sun intercepting the Earth is 5.5 yj per year, though not all of this is available for human consumption. The IEA estimates for the world to meet global energy demand for the 2 decades from 2015 to 2035 it will require investment of $48 trillion and credible policy frameworks. According to IEA, the goal of limiting warming to 2 degrees Celsius is becoming more difficult and costly with each year that passes. If action is not taken before 2017, CO2 emissions would be locked in by energy infrastructure existing in 2017. Fossil fuels are dominant in the global energy mix, supported by $523 billion subsidies in 2011, up almost 30% on 2010 and 6 times more than subsidies to renewables. Emissions. Global warming emissions resulting from energy production are an environmental problem. Efforts to resolve this include the Kyoto Protocol, which is a UN agreement aiming to reduce harmful climate impacts, which a number of nations have signed. Limiting global temperature increase to 2 degrees Celsius, thought to be a risk by the SEI, is now doubtful. To limit global temperature to a hypothetical 2 degrees Celsius rise would demand a 75% decline in carbon emissions in industrial countries by 2050. If the population is 10 billion in 2050, across 40 years, this averages to a 2% decrease every year. In 2011, the emissions of energy production continued rising regardless of the consensus of the basic problem. Hypothetically, according to Robert Engelman, in order to prevent collapse, human civilization would have to stop increasing emissions within a decade regardless of the economy or population. Greenhouse gases are not the only emissions of energy production and consumption. Large amounts of pollutants such as sulfurous oxides, nitrous oxides, and particulate matter are produced from the combustion of fossil fuels and biomass. The World Health Organization estimates that 7 million premature deaths are caused each year by air pollution. Biomass combustion is a major contributor, even though it is typically counted as renewable in energy statistics. In addition to producing air pollution like fossil fuel combustion, most biomass has high CO2 emissions.